Good day and welcome back to school. Ngayon, mag-uusap tayo tungkol sa robotics. Robotics is one very interesting application ng mathematics. And you can see that this is a factory ng Tesla, as we see in the news, and largely driven by robotics, no? Mga robot arms. So I made my own model, and that model is like that in CAD, para magawa ko siya sa totoong buhay. So let me try to explain things. So this schematic diagram is where we begin. When we move to the horizontal direction, so this claw sa diagram natin kanina, if we will move this way, and we want to keep the horizontal, we want to keep this center line level. We don't want to have any movement up and down. We just want to keep it moving in the direction ng horizontal. What we can see is this theta here, this angle here, we will rotate this arm to this angle because we have a motor here. Basically, it's driven by a servo motor here. So this motor will drive this arm, an angle theta, and you will notice that our motor here, so there's another motor here, this motor will have to turn not only theta, but it will have to rotate further than theta. So this is the original angle here, and this one is the new angle here. And if this is alpha, this one now becomes alpha plus 2 theta. So I need to add 2 times this rotation so that this can be maintained at level. Otherwise, hindi siya maging level. So kung i-rotate ko lang siya by theta, it will be somewhere here and ito will be somewhere there. It will not be straight up and level. So I need to do 2 theta for this angle here. And if I do that, you notice that this here, this angle there, now it has grown bigger too. So lumaki na siya. And how much does that grow? So if the original angle is, let's say, beta, if the original angle is beta, then this one is beta plus theta. So kung hindi mo siya lagyan yan, this arm will not be level. It will be like this way. So if you are holding something within this claw, halimbawa may binubuhat ito, is lifting up something, and bawal siyang mag-tilt ng ganyan, if you don't adjust, no, it will go like this, and the object that you are carrying either malalaglag or sisiksik dito sa punto na to, and maybe you don't want that to happen. Now, I think you probably sort of get the idea. So let's go back and start from this schematic again. Balik tayo dun sa original. And let's say now we want to move it up. Yung carrier na to, yung claw na to, gusto nating pa-move up. And we don't want any horizontal movement. Ayaw natin yung movement na to. We just want it to go straight up and i-maintain yung level pa rin yan. So what do we need to do? So again, this motor here, definitely we'll have to rotate somewhere there. Let's say we call that an angle theta. This one, kailangan ba siyang mag-retain to this angle or magbabago din? Definitely magbabago. You have to calculate. And let's say if this is alpha, so this one should be alpha plus a certain number, let's say constant times your theta. And then, obviously, this beta has also to change into something which is bigger, and this one will be beta plus another constant c d halimbawa times theta. So all in all, you can see that para ma-maintain yung end, which is itong flow na to, ma-maintain yung axis niya into one position. Like for example, in this case, we are now trying to maintain yung x. So x remains the same, y will change to tataas siya, pero yung x dapat ganun pa rin. And you can see that for us to do that using these endpoint motors, we have to rotate them and we have to calculate yung change na kailangan nating introduce to the internal angles ng mga yan so that makuha natin yung motion na gusto natin. So, every motion is computational. Isang galaw nito, may kaakibat na galaw itong motor na to and kaakibat na galaw itong motor na to. So, all them must work in tandem or in consonant with one another. Now, going back doon sa ating CAD model, as you can see, it has a base, and then it has a red na rotary member, and then there's a green na main arm, and then there's the magenta na secondary arm, and then the chrome yellow na claw, which is yung ginagalaw natin ngayon and articulate natin. So each member can be moved, articulated using motors sa kanilang mga endpoints. So tulad yung green na yan, niro-rotate natin. May motor dyan sa base niyan, ano? And then each, you can see the demonstration natin ng konting animation that each can move independently actually ng isa't isa. And each motor can be triggered individually. So this is now what it is in real life. Ayan. Parang hindi kasing ganda nung nasa model, ano? Well, we have to use popsicle sticks and some servo motors and yung cooking tin, cooking aluminum pan ng leche flan. And then we connect that to an Arduino microcontroller para lang mapagalaw natin. And using some simple mathematical equations, makikita nyo na napapaikot-ikot natin, napapagalaw na natin yung bawat members. And here it is now, para yung subukan natin yung ating theory ng galaw. So, okay, you can see the movement now. Na-retain natin yung horizontal axis ng claw while ina-articulate natin yung main arm tsaka yung secondary arm. Yeah, and that is our discussion for today. See you again next time and enjoy math applied in real life. Paki-subscribe po, click na rin the notification button so that maging updated kayo for everything and all the new things that are posted. God bless you. Stay healthy.